tagline that we communicated during the Ansys acquisition announcement is silicon to system. Because at the silicon level, we're very known. There is no silicon company in the world that does not know Synopsys. At the system companies, Ansys is very known because Ansys has and is the leader of multi-physics simulation, meaning mechanical, structural, fluid dynamics, and a car needed that stuff.
All right. Well, hi. Well, thank you very much for coming to the Ojo-Yoshida Report Tech Vision. We feature the important executives, especially for you. I mean, you are the new head of the company, the story, the EDA company, Synopsys. So we just wanted to not only introduce you to the audience, but also share the vision that you have, not only for the EDA business, but for the entire electronics industry, if I may.
That's great. Looking forward to it.
All right. Thank you. And we'd like to also introduce Bolaji Ojo, my partner in crime, co-founder of the Ojo-Yoshida Report. Say hi, Bola.
Hello, everybody. Thank you for coming on the show.
Thank you. Thank you.
Right.
This is Tech Vision, and you've been at Synopsys for quite a while before moving on to the position that you have now. So you do have a good background from which to look at the company and to kind of lay out for our audience what you see as the vision for the company going forward. You've addressed them during the earnings conference call, but we're interested in the big picture that you see ahead for Synopsys.
Yes, thank you for the question. So it's true. I've been here for 25 years, and I had the opportunity to do various jobs inside the company. So started as an engineer. Prior to that, I was at Intel as an engineer, then came to Synopsys as an engineer. And I was asked to move to the sales and marketing part of the company, which I spent quite a bit of time, about 12 years or so.
That's long.
A long time. And I loved it. I enjoyed it because I enjoyed being close to the customer. I loved being close to the customer. Then I was asked again to move and manage the product development for the company, the EDA product development for the company. And that was roughly around 2016 timeframe.
Okay.
And so I managed the R&D and development for our EDA products until 2020, where I moved to become a COO. Then about a year or so after president, which I had the visibility of the entire company. Then January 1st as CEO. So I tease Art. I tell him this is one of the best transitions. And I hope I'll do half as good of a job as he has done. Because, those are complicated. When you have a company like Synopsys, it's very important to bring people that understand the customer and the company at the same time. So that's my quick background. In terms of what do I see? Synopsys, if you go back not too long ago. So Synopsys is about 37 years old company.
Okay.
So if you go back about 10 years ago, 90+% of our revenue are the semiconductor chip companies. And if you look at us today, about 45% of our revenue is coming from system companies. The system companies can be in the hyperscaler, can be a mobile system company, can be an automotive OEM company. And the reason it expanded are two factors. One, our portfolio expanded, and I'll touch on that in a minute. The other is system companies are very interested in building, or if they're not building their own silicon, to have the ability to architect their electronic system. So we know many OEM companies where they have no intention to go all the way to building their silicon, but they're hiring silicon architects. Because they want to be able to, when they're interfacing with the chip suppliers, to be able to be very specific on what type of chip they need as they're envisioning their system.
And then to do that, they need EDA tools.
Actually, thank you. It's not the traditional EDA tools for chip design.
Okay.
So we expanded the portfolio where we have the ability to virtualize the chip, to model the chip. So before the chip is ready, so let's say if I am an OEM and I'm trying to outsource a chip from a semiconductor company,
Right.
that chip may not be available till a year from now.
Right.
But I want to be able to start architecting my electronic system, to verify it, to build my software. So we provide a model of the chip to the OEM.
Right.
And then when they start putting the system together, we have software and technology to help them architect it, validate it, and we become the bridge between the semiconductor company and the software company or the system company. Now, if you think of system companies that have been doing their own silicon,
right,
that's what they differentiate, because they have the silicon all the way up to that software stack.
Right.
So that's where we've been. Now, as we look ahead, and that was the thesis behind the acquisition of Ansys, is the end product, the system, be it a car or a data center or an industrial robotics on a factory floor. If we believe that the future is going to be more devices that they're smarter and interconnected, you have silicon proliferation everywhere.
Right.
And that silicon proliferation that's happening everywhere, you need to have the concept of the system when you're designing that silicon. And not only the electronic aspect of the system, but the electrical, the mechanical. Say in a car, you have sensors and actuators that is driving an action that is mechanical in nature for the car. Then how are you architecting that whole system as a holistic design, where electronics is the significant portion that is the brain and where the software is built to drive the electrical, the mechanical, etc.
Right.
So when we look toward the future, we see the opportunity growth will go from the chip to the electronic system to the end product system.
Let me ask you this. If I'm a system vendor and I don't work with you, right? I think I can make my own, build my own car. I've been doing this for a long time.
Right.
What changed? I mean, in other words, like who was actually providing tools for the vehicle design engineers to design vehicles up until now then?
Excellent question, because if you think about the car, let's stick to the car as an example. Pre-autonomous vision, pre-electrification, there was a tier of supply chain. Right? So the automotive OEM did not really, they had no idea who Synopsys was.
Yeah.
They had no idea for most of their semiconductor chip supplier who they were.
Right.
They were working with their tier suppliers, tier 1, tier 2, etc. Yeah. Then two things happened. One, the technology disruption, where cars are going to get smarter, connected. So the content of silicon is more and more.
Right.
The other factor, I think, that gave visibility to the chip is the COVID and the shortage, right? Where every OEM was stuck and they're trying to figure out, how do I get my chip supply?
Right.
If you were to ask me, even though I've been at the company for 25 years, up until about 3-4 years ago, I never met an automotive OEM because they had no reason to meet with me.
Wow.
Truly, they had no reason to meet with Synopsys because they had no intention. It's like we're so deep in the supply chain that they had no interest.
Yeah.
Now, given the push they have towards more silicon, even again, if they're building it or not, even if they're not building it, they want to be able to define the system architecture so they can work with their semiconductor suppliers. And we're providing that bridge. That's why right now our tagline that we communicated during the Ansys acquisition announcement is silicon to system. Because at the silicon level, we're very known. There is no silicon company in the world that does not know Synopsys. At the system companies, Ansys is very known. Ansys is very, very known because they sold many of their mechanical software to simulate the mechanical, the airflow, the fluid dynamics. So Ansys is super known in that space. but not necessarily Synopsys.
So the system architects in a vehicle company, for example, they were using Ansys already.
That's right.
They
That's
were
right.
already using Ansys.
Yes, they were using Ansys because Ansys has and is the leader of multi-physics simulation, meaning mechanical, structural, fluid dynamics, and a car needed that stuff. Regardless if it's based on an engine and a transmission or if it's electric, you need that mechanical aspect of simulating the car. You needed some electronics, but the electronics were just components you buy. Now, given the increased electronics content to become the brain of the car, that's where we're becoming a bigger part of that supply chain and playing a role.
Essentially, it seems that the profile of your customers has changed dramatically since over the last several years, and much more so than when you first joined the company. Now, the question that comes to my mind then is, can you talk about the profile that you see going ahead? And is it sustainable? Are these companies going to stick with you through all of these, or is this just a one-time thing? They get over the challenges of the supply chain and procurement, and then they go back to their old ways. Are these changes going to be permanent?
Excellent question. We've seen over the last 3 years, since the squeeze of the supply chain, number of and we're sticking to the automotive OEMs, that they got excited and they even had plans to build their own chips. And it kind of died off. Because building a chip is not easy, as we know. Building a chip is the most complicated and requires very sophisticated skills to do it. So, and those skills are in shortage today. There aren't engineers that they're just looking for jobs on the street to satisfy the demand for that talent. So, and you have other OEMs that they went all the way down to building some chips. So there are many automotive OEMs that they're building chips and they're outsourcing some of the spec to other people to build a custom chip for them. So that is happening today. Now you fast forward and envision the car of the future. If you believe the cars are going to be connected to one another, meaning they're going to be communicating with one another, they're going to be communicating to the city, to the user, that user experience, there won't be a driver, the passenger experience in the car is going to be based on the differentiation that OEM is providing. Which is through electronics, through the software, through the services they'll be providing. Now, they don't have to design all the way down to the chip level. I think very few will be able to make that investment go all the way to the chip design level. But they must have an architect for the electronics and this electronic system in the car that is tying to the rest of the car, the mechanical, the electrical, the etc. Then you think of that end product as a multi-domain system that you're designing and optimizing.
And especially at a time of software-defined vehicle.
Exactly.
That becomes very important, because it's not like you build this chip and you don't care about the rest of the vehicle. You have to, whatever changes in software you make in this chip will have a profound impact for the rest of the vehicle.
Exactly. And as you know, when you have over-the-air update of that software, you're not changing the chips. The chips are the chips. They're sitting in the car. But how did you architect the whole system that you can support that software-defined actions you need to take?
Are we looking ahead at more changes within the ecosystem? I mean, this is tech vision after all. So I'm curious, when you look ahead, do you see more changes ahead? And if you do see those changes, how is Synopsys prepared to meet them?
Yes, so our world of ecosystem has been the foundry world. Because in the EDA world, when we think ecosystem, immediately you think of the foundries. You think of Intel, of TSMC, of Samsung, of GF, etc., etc. And the reason we think of that world as a very interconnected with EDA, because you cannot design a chip on a foundry without having EDA enabled on that foundry. You just cannot. So we work very closely with that ecosystem.
Yeah.
And same thing on IP. IP is a huge differentiator for Synopsys because if you look at designing a chip,
Yeah.
there are many standard interfaces. They're not differentiating the chip. So instead of wasting your skills and talent and time on designing a standard,
Yeah.
you just get it from Synopsys as a Lego block, you put it in your chip and you move on.
Yeah.
So the foundry ecosystem has been essential and very central to EDA and vice versa. The moment you go to system, the ecosystem is going to expand and change because the automotive ecosystem is going to be different than the aerospace, than the health, than the industrial. And those are places we still have a lot of learning and maturity in order to define it, because what we've done in silicon is very different in terms of maturity than the rest of the ecosystem. So this is where there are many other opportunities to continue on defining the ecosystem, defining how do you have interoperability with that ecosystem. So not each car OEM are defining their own ecosystem per se.
I see. Huh. You know, you touched upon IP, and I just want to drill down a little bit because my understanding is that if you look at the IP market, actually, Synopsys is the world's second largest IP supplier, right?
Yes.
I mean, the first one is ARM, and you're the second, right?
Right.
And it's just so, but the reason why you need IP is to serve your customers.
Yes. So a couple things on IP.
Yeah.
We started actually the IP business exactly 25 years ago. The anniversary is this month of our IP business. And the vision was the chip is going to become more and more modular, meaning there are components that you the customer, needs to put their differentiation and build their product innovation and differentiation.
Right.
The chip needs to interface to another chip or interface to the outside world.
Right.
And those interfaces, they're standard. Like the USB is a standard, the PCIe, etc. There are many, many standards.
Right.
And the complexity of building those standards started becoming higher and higher because especially when you're moving from a 5 nanometer to 3 to 2 nanometer, and the resources, the energy it takes to build those standards is not an easy task. So the market over the last 25 years has moved from our competitor used to be our customer initially. And it's sad to say it this way, where the customer used to say, I don't need a USB from you, I have it. I don't need a DDR from you, I have it. But then when the challenge became on resources, on the quality of the IP, etc., they wanted to focus their energy where they differentiate. And all those customers outsourced their IP to Synopsys. And that's why we became the leader in interface IP. But it requires a huge scale.
Right.
Like we're talking inside Synopsys, we have many thousands of IP developers inside the company.
So the maintenance of IP has become so huge to the point that people just didn't want to do all the
exactly
Right.
Because they need to focus on where they differentiate, and since the standard is not differentiating them, they go to Synopsys. Now the second factor, which accelerated over the last 3 years, is geopolitical, where most customers are trying to have optionality from a foundry point of view.
Right.
And if you're a customer that's developing an IP on Foundry A, or not an IP, you're developing your chip on Foundry A.
Yeah.
Now you need option 2 to have an option 2 foundry for whatever reason.
Right.
We have the IP on all foundries. So the customer, for them to develop their IP on Foundry A and Foundry B is tremendous amount of effort and risk.
Right.
For us, we have developed it, we validate it, we have silicon, proven IP. So it gives the customer optionality in the world we're in right now.
This, gives me I was at Intel Foundry event yesterday.
Yes.
And there was Microsoft who came
Yes.
at the event. That was on a video presentation.
Mm-hmm.
But it essentially talked about that Microsoft is going to build a new chip using Intel Foundry's 18A, right?
Mm-hmm.
But last year, they did announce 2 AI chips, and those 2 chips are going to be manufactured by TSMC.
Correct.
So my question to Intel was that, does that mean that Microsoft is going to switch from TSMC to Intel, or is this something different? And the answer was no. Maybe in the years past, that might be the case. But now with the advancements of EDA technology, it becomes possible. You use the word optionality, but it's the second sourcing has become totally important. Do you think that's going to be possible? I mean, it's like I'm just example of. I would imagine Microsoft is making a maybe big chip, but I think it's an AI chip. Is it possible?
It's actually a very good example to use. They don't have to switch from a TSMC to Intel for them to have the investment to consider optionality. Let's assume you need more capacity.
Yeah.
Okay.
And your capacity limited. So having that optionality is very important.
Right.
Now, from a practical point of view, designing with optionality is very hard because you cannot double your design engineers and
For
double
this, right.
It takes a significant effort. What the role we're playing, if you want to go on Intel Foundry, we had an announcement with Intel Foundry, if I'm not mistaken, in a June-ish timeframe, where we, Synopsys, are the 18A and 3 nanometer IP portfolio supplier of choice. Meaning, if I am Microsoft and I'm designing with TSMC and I'm buying the IP from Synopsys, if I want to go to Intel, I want to make sure I have the same IP, that the same one I'm using from Synopsys, but on Intel Foundry. So now we have it on Intel Foundry and on TSMC, and of course on Samsung, on GF, on many other. So that was step one.
Yeah.
I call it the on-ramp on the highway. So you cannot get on the highway without having the on-ramp built. So we built the on-ramp. So right now we have the on-ramp. Then the second challenge that the customer are saying, okay, that's great. Now, how do I move my other part of the design from here to here to here?
Right.
And it does not have to be from Foundry A to Foundry B. Even if Microsoft wants to stay with TSMC, but go from 3 nanometer to say 2 nanometer, that's where AI is playing a big role. This is where we have AI. We call it AI for retargeting. So you go from a 3 nanometer to 2 nanometer using AI. AI will take your design and retarget with a new library, with a new set of requirements on 2 nanometer to share with you where's the maturity of that technology. On the digital portion of the design, we have a fairly solid, mature technology. We actually released it into the market in 2020. So it's been almost 4 years customers are using it for that purpose. But every chip has other portion besides just digital. There is analog design, etc. There is in earlier stages. It still require manual human designer effort to do it. So what we're doing as an industry and as a company, on IP, it should be a check. You have it.
Yeah.
On EDA, we're trying to implement AI to make the optionality within the same foundry or between foundries less resource intense.
I see.
No, I kind of just wanted to follow up on the AI part because it's such a big part of what you're doing now.
Okay.
So you've talked about a specific example. I'd like you to look within the company and talk about other areas of your operations where you are also applying artificial intelligence.
You know, yes, but don't ask me to measure it yet. I mean it. And this is something that I push the team very hard, which is, here's how I push the team on it. You cannot convince me that every function of the company cannot be looking at areas where they can use AI in order to improve the output, better quality output, and reduce the time to get to that output. And we identified many lanes, finance, marketing, legal, engineering, sales, etc. And that happened about a year and a half ago, where we put clear objectives for each lane to assess technology and start implementing into our workflows, how can we improve our efficiency and effectiveness. The reason I was joking, I said, don't ask me to measure where we are today. We're at different levels of maturity. In some places, they're seeing 30, 35, 40% on a task to be able to leverage AI and say, wow, this is impressive. I was able to get a better outcome faster using AI. In other places where it's more sophisticated, there is no training model that you can just grab and use. You have to train your own model. Let's say like our software development engineering aspect, we're in a much earlier stages of maturity. However, myself, the team, there is no disagreement. It's a significant opportunity for disruption and innovation.
Right.
Because the same challenge I described, that our customers cannot get enough skills, same with us. We have to go to that next level of maximizing the technology in order to continue on accelerating innovation.
Okay. I have last question, actually.
Yes.
You mentioned IP, right?
Yes.
And we were talking about IP in a traditional IPs for SoCs.
Yes.
I want to talk about chiplet IP.
Yes, thank you.
Are you going to be in that business?
First, thank you so much for asking the question. You're right. I described IP in terms of the monolithic chip design.
Right.
Actually, on the earnings call yesterday, I outlined 3 examples. UCIe, which is the interface standard between chiplets.
Right.
PCIe Gen 6, we're talking about PCIe Gen 7. So we are absolutely leading. Not only are we going to be in that business, we're leading many of these standards bodies. We're part of these committees defining those standards, and our scale helps. Because as I mentioned earlier, we have many thousands of engineers working on IP. Scale matters in IP because you cannot develop an IP and for Foundry A and say, I don't have resources to do Foundry B, Foundry C. Or you cannot say, I don't want to develop an IP because there's only 3 customers that they will use it. Because they're going to be the next standard. If you did not develop the first one, it's very hard to catch up on the next one. If you did not have PCIe Gen 5, how will you develop the Gen 7? Absolutely. For us, we talk about it a lot, the multi-die package, the chiplet approach is a significant opportunity for EDA and IP.
Wow.
You just maybe my last question also, you've been growing. And now you're making a major acquisition. So what is the future like financially?
You know, it's so beautiful to see our company in the last 3 years, 17% CAGR revenue growth in 3 years. At the same time, we passed to EPS 26% CAGR. So we're improving both the top line, the bottom line. As we look ahead, we're committing externally that it's a double-digit growth company. When you look at Ansys coming in, the TAM will grow from 18 billion TAM we're in to 28 billion. And continued on committing is a double-digit growth. We'll be growing above the market. The market grows at around 11%. So we'll be above market growth given the scale that we have. So it's an exciting time to be in our industry and to be at Synopsys.
All right.
Thank you.
This concludes our presentation, but it was very good.
Thank you so much.
It was wonderful.
Thank you. Thank you
It's
for
really
taking
been
the
a
time.
pleasure, and good luck with everything and the acquisition.
Thank you.
Yeah.
And I look forward to interacting with you in the future.
Yeah.
Thank you.
This is very good. Thank you.
Thank you.
I learned a lot.
Thank you. Bye.
Bye.
Bye-bye.